Hello my beautiful students, so welcome back to KCET Masterstroke series. So here we are going to start the first PU lesson, that is some basic concepts of chemistry. So yes, if you want to get top 1000 rank in your KCET examination, then Masterstroke series is going to be a life savior for you. So yes, without further delay, let's get started. So here you can see some basic concepts of chemistry, first PU chapter that we are going to start today. So these are the things that you are going to learn. First, a little bit we will discuss about the law of chemical combination, Dalton's atomic theory, atomic and molecular mass, mole concept, percentage composition and stoichiometry. Okay, so let's proceed with the first thing, that is law of chemical combination, Dalton's theory and atomic and molecular mass. In the law of chemical combination, we have total 5 laws. They are basically law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law and Avogadro's law. Next, in the atomic and molecular mass, we have to get the proper idea about the atomic mass, average atomic mass, molecular mass and molecular formula. Let's proceed. First, we will go one by one law. So first, as you can see, law of definite proportion. Okay, law of conservation of mass at first. As you know this, matter cannot be destroyed, cannot be created, right? So this thing is the law of conservation of mass. I'm not going to detailed discussion about it because that will be irrelevant for your KCET. Okay, law of definite proportion. So for this case, you can see a given compound always contains exactly the same proportion of elements by weight. Means, let me just give you one example. Let's say you have water, okay, and now just collect water from different source. Collect water from your filter, collect water from pond, collect water from a waterfall. You will see always the weight ratio of the hydrogen and oxygen, it will be similar. Okay, it will be 1:8 all the time from wherever you collect that thing, right? So that is your law of definite proportion. Next, law of multiple proportion. You can see if two elements can combine to form more than one compound, the masses of one element that combined with fixed mass of the other element are the ratio of small whole number. So let me just explain this a little bit. See, if carbon and oxygen, they combine, they can form CO2 and they can form carbon monoxide as well, right? So now if you just find the ratio, here the mass of carbon is fixed, right? So mass of carbon I am taking as 12. Here it is combining with 32 gram of oxygen, right? And here I am having 12 gram is to 16. Okay, so now fixed mass is carbon. We will not take the carbon, we have to take the ratio of oxygen in both the cases. So for this case it is 32 and for this case it is 16. You can see 2:1, it's a simple ratio. Okay, so that's what it is, law of multiple proportion. I guess it is clear to you. Let's proceed. When a gases combine or are produced in a chemical reaction, they do so in a simple whole ratio by volume. So if you just simply check this thing, N2 plus 3H2 will give you 2NH3. Okay, here also 1:3 ratio they are maintaining. So the ratio must be very much small, very much simple. Okay, it should not be something like, let's say 11:19, just a random numbers I am telling, 17:35. It should not be like that. It should be a very simple whole number ratio. That's it. Okay, next, Avogadro's law. Equal volumes of all gases at the same temperature and the pressure should contain equal number of molecules. So this thing I can explain a little bit because from here itself the mole concept comes. Okay, so let's say I have 3 container. Okay, so all of them are, let's say, 100 ml. They are kept in room temperature. Okay, 100 ml. They are closed and kept in room temperature. Let's say here I am having O2, here I am having, let's say, N2, here I am having ammonia. Okay, so now my question is, for which case I will be having maximum number of molecules? Okay, so let me tell you, maybe there are different gases, but as the volume is same for all the cases, they will be having same number of molecules in every container. Now let's say if I make the container 22.4 liter, my container is 22.4 liter. Then the number of molecules I will be having, that is called Avogadro number. Okay, then the number of molecules, it is Na, that is the Avogadro number. Okay, so what is Avogadro number? That is 6.023 into 10 power 23. So these many number of molecules will be there when the volume of the container will be 22.4 liter. Okay, and mass of the substance will be equivalent to their molecular mass. Okay, I guess this is clear. So if I am having 22.4 liter volume of a container, then how many molecules of any gases will be present over there? That is Avogadro number. And what will be the weight? That is their molecular weight. Okay, so let's proceed. Okay, so one more thing that I want to tell you, yes, Deeksha Karnataka channel already have launched ABHYAS KCET test series. So if you have not enrolled, please enroll yourself, because that's going to be really beneficial for your upcoming preparation to boost up your knowledge in KCET, right? So they will provide 35 mock tests and chapter wise PYQs as well. So yes, without further delay, take this test series and just grab the opportunity to boost your rank up to 10,000, top 10,000 in KCET examination. And also along with the ABHYAS KCET test series, they already launched KC30 batch. In that batch, you will get a proper structured schedule since last 30 days of your KCET examination. That's gonna be start from 21st of March, and here from the expert faculties you will get the classes, live online session. Every day is going to be a doubt solving session. Entire PU1 and PU2 syllabus is going to be covered. PYQs will be there in the test format. So what else you need for the KCET preparation? So yes, go and grab the opportunity. So till 25th the offer will be valid like 2499, but later on the price may vary. So yes, without further delay, please go and grab the opportunity. Okay, let's proceed. Here comes the Dalton's atomic theory. Though you already had been through this multiple times, but sometimes some statement based question comes out of this particular thing. So that's the reason a small revision I kept here. Okay, what are the statements? What are the theory says about? It is matter consists of indivisible atoms. Okay, the particles, those are called atoms. Next, all atoms of a given element have identical properties, including identical mass, and atoms of different element, they differ in mass. Okay, next, compounds are formed when atoms of different elements, they combine in a fixed ratio. Okay, next, the chemical reaction involve reorganization of these atoms, and these are neither created nor destroyed during the chemical reaction. So these are the postulates of the Dalton's atomic theory. Okay, let's proceed further. Here we are going to discuss about the atomic mass at first. So one atomic mass unit is basically equal to 1/12th time of the mass of a carbon 12th atom. Okay, and what is average mass? Average mass is calculated taking all the isotopic elements. Okay, next, if I proceed further, molecular mass. Molecular mass is basically the sum. Okay, is the sum of the masses of individual elements that is present within the molecule. Okay, so definitely it will be obtained by multiplying the atomic mass of each element by the number of its atoms, that is adding them together. Let's say I am having H2O. Okay, in H2O I am having 2 hydrogens, so you have to multiply 2 with the atomic weight of hydrogen. That will give you the molecular mass. Okay, 2 into atomic weight of hydrogen plus oxygen. That's it. Okay, next, formula mass. This is used in case of the ionic compounds. Okay, let's proceed. Okay, mole concept, this particular thing I already told you. Okay, if you are having same volume, then any element you take, any gas you take, okay, they will contain same number of moles, right? Same number of molecules within it. And if the volume is 22.4 liter and it is having the molecular weight amount of the element, then it will be having 6.023 into 10 power 23 atoms. That's it. Okay, so let's proceed further. So here you can see how this is a kind of brain map. Okay, so here you can see number of moles if I want to find out. Okay, how I should get it? If the given mass is mass is given, okay, and they are asking what is the number of moles. Okay, so first let me just write one thing. One mole it indicates 6.023 into 10 power 23 molecules or particles. Let me write particles. Okay, that also indicates 22.4 liter volume. That also indicates the molecular weight. Okay, this thing you remember. Now number of moles, how I should get? That is the given mass divided by, you can see mass in grams, that is given, divided by molecular mass. Okay, one more way to get it, if it is given in terms of volume. Okay, that is, let's say given volume divided by 22.4 liter. Okay, so this is the way you can just calculate the number of moles. Okay, I guess you understood. Even a number of molecules, if you want to find out, you have to just divide it with the molecular mass. You will get the number of molecules present out of it. Okay, so I guess it is clear. From here only you will get the all information, okay, that is needed to solve the numericals and all. Okay, so let's proceed further. Here you can see percentage composition, mass percentage of an element. It is given by mass of that element in the compound divided by molar mass of the component into 100. So one numerical we will do, then it will be clear to you. Okay, so here question is calculate the mass percent of different element present in sodium sulfate. Okay, let me just do it. So basically mass of sodium, molecular weight of sodium, if I write, molecular weight of sodium is basically 23 almost. Okay, so molecular weight of sulfur is 32. Okay, molecular weight of oxygen is basically how much? It is 16. Right? So but here in this particular case, how many sodium is there? 2 sodium is there. So let me find out the mass percentage of sodium. If I find out, that is going to be basically 2 into 23 divided by how much they give? Molecular weight you have to calculate. Okay, let me just calculate the molecular weight of sodium sulfate, Na2SO4, right? So molecular weight is going to be 23 into 2 plus 32 plus 16 into 4. Okay, so if you calculate this, your molecular weight come almost 142 gram per mole. Okay, so divided by 142 gram if you do. Okay, so then from here into 100, definitely into 100. So if you calculate this, your answer will come up to be something like 32.37. Okay, next, mass percentage of, let's say, sulfur. So that's going to be only one sulfur is there, so we can do it simply by 32 divided by 142 into 100. So if you just calculate that, your answer will come up to be something like 22.5%. Okay, and next, if you calculate the mass percentage of oxygen. So how many oxygens are there? 4 oxygens, right? So 4 into 16 divided by 142 into 100. Okay, you will get 45.07 almost this percentage. Okay, so this is how you should target this type of question. I guess you understood this. Let's proceed further. Okay, so here comes the empirical formula and molecular formula. So what is empirical formula? That is the smallest ratio of the atoms that is present in a compound. And what is molecular formula? That is the actual formula of the compound. So how you can relate? So you can relate molecular formula equals to molecular formula equals to empirical formula whole n, right? So what is n? N is basically molecular formula mass or molecular weight, simply you can write, divided by empirical formula mass. Okay, if you do this thing, you will get the n value. Okay, so yeah, let's proceed further. Okay, a pure compound contains 2.4 gram of carbon, 1.2 into 10 power 23 atoms of hydrogen, okay, and 0.2 moles of oxygen atoms. It's empirical formula we have to find out. Okay, let's do it. So here number of moles of carbon, hydrogen and oxygen we will find out. So number of moles of carbon, 2.4 gram is given. So given weight divided by molecular weight, that is 12 gram. So from here we will get 0.2 gram. 0.2 gram per mole, 0.2 mole, sorry, 0.2 mole, right? Now number of moles of hydrogen, if I do, atoms are given, so 1.2 into 10 power 23 divided by 6 into 10 power 23. So here also it will come up to be 0.2 mole. Okay, now if I proceed for oxygen, number of moles of oxygen, it is already given, that is 0.5 mole, right? Sorry, 0.2 moles. Okay, so now carbon is to hydrogen is to oxygen, if I find out, that is 0.2 is to 0.2 is to 0.2. So hence 1 is to 1 is to 1. So from here I can write that the formula is basically CHO. Option D is going to be the correct one. I guess this is all clear to you. Let's proceed further. Okay, a compound consists of 52.17% carbon, 13.04% hydrogen and 34.78% oxygen. Find the molecular formula of the given molecular weight of the compound. Okay, the molecular weight is given as 46 gram. Okay, let's do it. Okay, so let's proceed with the problem. So we will make a table. Here we will write the elements. Here we will write the number of moles. Okay, and once the number of moles we will get, then we will find out the ratio. Okay, so first option is, you can see it is carbon. First thing is carbon. Okay, so how much they are saying? 52.17%. So what I have to do? 52.17 divided by the molecular weight, 12. Okay, so it will come up to be something like 4.3. Okay, next I will go for the hydrogen. How much hydrogen they gave? 13.04. 13.04 if I divide with 1, it will almost give you the same thing, right? 13. Okay, I'm just taking as the simplest ratio. Okay, so hydrogen and oxygen. Oxygen, how much it is given? 34.78. Okay, divided by 16. So if you do this, almost 2 point something will come. 2.27, right? 2.1, like that you will get. Okay, now in order to find the ratio, simple ratio, I will divide this with the smallest number. So this is the smallest number you can see. So 4.3 divided by 2.1, then 13 divided by 2.1, then 2.1 divided by 2.1. Okay, so that's almost going to be how much? This almost going to be 2. Okay, this almost going to be 6. Okay, this almost going to be 1. Okay, so from there I can write the carbon is to hydrogen is to oxygen ratio is coming something like 2:6:1. Okay, so in accordance to that, I can write the formula C2H6O. Right, C2H6O. This is my empirical formula. This is my empirical formula. Right, so now empirical formula mass we have to calculate. Empirical formula mass. How I should calculate? Carbon I am having 2. So 2 into 12 plus 6 plus 16. So if you do 24 plus 6, 30 plus 16, 46. Okay, 46 gram you are getting. So now N if you calculate, N is basically molecular weight, that is given 46 gram divided by empirical formula mass, that is also 46 gram. So N value is coming as 1. So from here molecular formula you are getting something like C2H6O, right? So in accordance to the option, this going to be option A. Means if I just write it like this, C2H5OH. Okay, so option A is going to be the correct one. Okay, I guess this is clear to you. Let's proceed further. Okay, this is the overall percentage is given out of here. Okay, so this is the percentage, is the number of moles, okay, that we already calculated. Okay, and simple ratio also it's already calculated. Okay, 4.3, here 13, here 2.1, like that. Okay, so I guess it's clear. Let's proceed further. Okay, so here we are going to discuss about the stoichiometry. So stoichiometry is important to calculate how much product will form from a certain amount of reactant. Okay, and definitely for this particular case you need a proper balanced equation. Okay, so like this, here you can see combustion of methane, the reaction is properly balanced. From here what you can see, 1 mole of methane will react with 2 mole of oxygen to give you 1 mole of CO2 and 2 mole of H2O. Okay, further if I simplify it, this is 1 mole means 16 gram. 16 gram is the molecular weight, right? Okay, 16 gram of methane will always react with 2 into 32 means 64 gram. 64 gram of oxygen to give you 44 gram of CO2 and 36 gram of water. Okay, this is how actually you can analyze. In the form of volume also we can analyze. So 1 mole means 22.4 liter, right? 22.4 liter methane always will react with 2 into 22.4 liter of oxygen to give you 22.4 liter of CO2 and 22.4 into 2 liter of water. In terms of volume also we can explain. Okay, in terms of particle. Okay, see 1 mole means Avogadro number, means Avogadro number of methane will always react with 2 into Avogadro number of oxygen to give you Avogadro number of carbon dioxide and 2 into Avogadro number of H2O. So these many information I will get out of the balanced reaction, means the stoichiometry. I guess this is clear to you. Let's proceed further. Okay, so let's proceed further. Here you can see one problem is there. Equation is already balanced. Okay, so how many grams of HCl react with 5 gram of manganese dioxide? Okay, fine. So from the equation I can get the information that okay, let me just find out the molecular weight of manganese dioxide at first, because this is unknown. Okay, let's do. So if I do MnO2, then manganese is how much? Manganese is 55, I guess. 55 plus 2 into 16. Okay, so if I do 55 plus 32, how much I will get? 55 plus 32, right? So you will get something 87, right? Okay, 87 gram per mole, right? So from here, what information I am getting? You can see 4HCl, okay, 4HCl is reacting with 1 mole of MnO2. Okay, HCl means 35.5 plus 1, 36.5, means 4 into 36.5 gram of HCl is reacting with 87 gram of MnO2. Okay, so from there I can use the unitary method then. So from here I can write 87 gram MnO2 requires 4 into 36.5 gram HCl, right? Hence 5 gram of MnO2 will require 4 into 36.5 divided by 87 into 5 gram of HCl. That's it. If you just calculate this, your answer will come up to be 8.4. Okay, 8.4 gram. That's it. So just write the mother equation. Okay, whatever the reactant they are talking about, pick them. Okay, just analyze their stoichiometry and proceed with the unitary method. That's the way you should proceed. Let's proceed with the next question. Limiting reagent. Limiting reagent means the reactant which gets consumed first, okay, and limits the amount of product formed. Definitely, if let's say nitrogen plus 3H2 will give you 2NH3. Okay, so this is basically your 28 gram, right? 28 gram, and this is basically 3 2s are 6 gram, 6 gram, and here 17 into 2, 34 gram. Okay, so now let's say 28 gram nitrogen will always react with 6 gram of hydrogen to give you 34 gram of ammonia. But let me just tell you, let's say 28 gram N2 is supplied, but in place of 6 gram of hydrogen, they supplied only 4 gram. Right? So 28 gram will react with 4 gram of hydrogen and it will give the certain amount of ammonia. But then some unreacted N2 will be there, but hydrogen is not there. After 4 gram it is over. So as hydrogen is fully consumed, the reaction will stop. Though I am having excess nitrogen, but excess nitrogen can't react, right? Because it is not having hydrogen. So that's the reason, because of limiting supply of the hydrogen, the reaction is getting stopped. Okay, so amount of hydrogen decides the product that will be formed out of it. This is limiting reagent. Okay, I guess it is clear to you. Okay, let's proceed further. Here you can see 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, so let's at first write the equation. So what is the equation basically? If you are having magnesium plus oxygen, that will give you MgO, magnesium oxide. So what you have to do at first, you must have to balance the reaction. Okay, so if I want to balance, it should be 2Mg like that. Okay, so now from here, moles of magnesium we can calculate. Number of moles of magnesium I can calculate. So 1 gram they have given, right? 1 gram. So from here, what information you got? 2 mole of magnesium will always react with 1 mole of oxygen, right? Okay, so let's calculate the number of moles of magnesium. 1 gram divided by molecular weight, that is 24 gram per mole. Okay, so if you just calculate, then it should be 0.04, I guess, 0.04. Fine. Now number of moles of O2 if you calculate, So that is also given 0.28 gram, right? 0.28 gram divided by molecular weight is how much? 32 gram. Okay, so if I calculate this, then you will get 0.0 one more zero should come because 2 digit ahead. Okay, so 0.00887. Okay, this mole, this mole. Okay, so for the simplification you can just divide the digit, means always keep the numerator greater. Okay, just make it 280 and divide with the 10 power something. Okay, then you can just do the calculation 280 divided by 32. Okay, and divide by some 10 power something. Okay, it makes the calculation easier. Okay, I did it directly, I just assumed that decimal like that. Okay, but you can always proceed with this method. For this case also, here I have taken 100. Okay, so 100 divided by 100, if I do, it's same, right? So same thing you do here. Okay, so I guess this is clear to you. So number of moles we got. Now what we have to proceed with? We have to find the limiting reagent, right? So they are asking which reactant is left in excess and how much. Okay, so always remember that 2 mole of magnesium will always react with 1 mole of O2. Okay, then let's proceed further. So by the equation I'm getting the information 1 mole of O2, they requires 2 mole of magnesium, right? So now from that case I am getting 0.0087 mole of O2, means how much magnesium I need. Okay, so 2 by 1 into 0.0087 mole of magnesium. So if I just calculate this, I should get 0.0174 mole of magnesium, like that, close by something like that, 0.017 moles of magnesium. Okay, but they gave 0.04 mole. Okay, I need 0.014. Okay, I guess this is clear to you. Now you can see the next step, that is we have to check how much we need and how much it is given. So we basically need 0.0174 mole of magnesium. We need 0.0174 mole of magnesium, but given is 0.04 mole, right? Means it is more. Okay, so from here I can write magnesium is excess. Okay, I guess this is clear to you. This much magnesium I need, but it is given as 0.04. I need 0.01. Right? So magnesium is excess. So which one is limiting? So oxygen is limiting. Okay. So first of all, oxygen is limiting. Now you have to find out how much. Okay. So this much magnesium now will react. This much magnesium now it will react. Okay. So how I should calculate that? See, 2 mole of magnesium. 2 mole of magnesium will need 1 mole of O2. 1 mole of O2, right? Hence, 0.0174 mole of magnesium will need 1 by 2 into 0.0174 oxygen, right? So from here, if you just do the calculation, it will come up to be something. Let's proceed with the next question. 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, excess reactant you have to find out. So at first let's write the reaction. So what is the reaction? Magnesium plus oxygen will give you MgO. Let's balance it. From here I am getting the 2 Mg and 2 MgO. right? So from here what information I'm getting? 2 moles of magnesium will react with 1 mole of oxygen, right? Okay, so now what you have to do, we have to find out the number of moles of magnesium and number of moles of oxygen from the given data. So number of moles of magnesium, 1 is given, 1 gram is given, divided by molecular weight of magnesium is 24 gram per mole. Okay, so if you do the if you do the calculation, so basically what we do, how we calculate by, like, this is for the KCET purpose, right? So you have to do the calculation all by yourself. So just take it as 100. Always take the numerator more, okay, by adding or multiplying 10 power something. So if I multiply and divide 100, there is no issues, right? So if I just multiply this thing with 100 and divide with 100, the numerator become more, right? So now divide by 100, that we can adjust later by the decimal exchange. Okay, so if you just do this, definitely your answer is going to be something. Okay, so your answer is going to be 0.041. Okay, if I just proceed like that. Okay, so this is the number of mole. Okay, now number of moles of oxygen, if you do, how much they gave? They gave something 0.28. 0.28 they have given, and I have molecular weight something 32 gram per mole. So again, here you can just take it as 280 and divide with something. Okay, so your value should be something like something 87. Okay, so 0.0087, like that mole. Okay, you should get. Fine, so number of moles we got. Now we will see, if I am having this many moles of oxygen, how much magnesium I actually need. So from the question I can see that 1 mole of O2 requires 2 mole of Mg, but it is given that 0.0087 mole of O2 means 2 by 1 into 0.0087. So if I just calculate, it should come up to be something like 0.0174, like that, 0.0174 it should come. Okay, so this many mole of magnesium I need, but see how much is supplied. Supplied is 0.04 and I need 0.01. Right? Supplied is 0.04 and I need 0.01. So which one is more? Definitely supplied is more, right? So magnesium is basically excess. Right? Magnesium is excess. Oxygen is limiting. Done. Now magnesium you got excess. Now how much, that you have to calculate. So how you should calculate? So number of magnesium excess that equals to, I can give, that is given, that is 0.01 minus 0.017. Okay, so if I just simplify it, 0.04 minus 0.01, so it should give you something like 0.02. If I just simplify this thing, 0.02 something, okay, 0.02 something you will get. Okay, from there weight, if I calculate weight of magnesium, if I calculate, then you should get molecular weight 24 into number of moles 0.02. So that will give you something like 0.5. Something 0.48 something it is coming. So 0.5 I can take. So your answer is going to be B. So a lot of approximation I have taken because I directly did the calculation here. So that you can also understand what type of approximation you can take here while calculating, how to shift the decimals and all. Okay, so this type of approximation I guess you should learn while practicing the numerical only. Okay, so don't be dependent upon the calculator, try to do it by yourself, okay, and try to simplify this thing. Okay, so I guess it is clear to you. Let's proceed. Okay, so here we are going to discuss about the concentration term. First we will discuss about the mass percentage. Mass percentage is basically mass of the component in the solution divided by total mass of solution into 100. Okay, next we will discuss about the okay, one problem is there. Calculate the mole fraction of ethylene glycol in a solution containing 20% ethylene glycol by mass. Okay, fine. So first what we have to do, we have to calculate the molecular weight. Okay, so I'm having C2H6O2. C2H6O2 means 12 into 2 plus 6 into 1 plus 16 into 2, right? If I calculate 24 plus 6 plus 32, 62 I guess. Okay, 62 gram. Okay, so now what we have to do, mass percentage means 20% they told. 20% means 20 gram is given, right? N of C2H6O2, it's basically 20 divided by 62 gram. Okay, so if I just calculate this, it should come up to be something like 20. If I just make it 200, then 0.3 at first it will go, then I guess 0.32 mole. Okay, now number of moles of water. Okay, for number of moles of water, I need to know what is the amount of water that is given. So 20% means 20% of ethylene glycol means 20 gram in 100 gram solution, right? Hence, amount of water if you want to find out, then 100 minus 20, that is 80 gram, right? So given weight is 80 gram divided by 18. Okay, this gram per mole. Okay, this is easy calculation. You can proceed with 4.4 something mole. Okay, so number of moles we got. Okay, now mole fraction. Okay, so mole fraction, how I should calculate? Mole fraction of ethylene glycol, I'm just writing ETG. Okay, so number of moles of ETG divided by number of moles of ETG plus number of moles of H2O. Okay, so number of moles of ethylene glycol is how much? 0.32 divided by 0.32 plus 4.4. so the denominator part is going to be something like, if you calculate 0.32 plus 4.4, it should come up to be something like 4.76 kind of thing, and above 0.32. Okay, so if you just find out this thing, 0.320 if I do, then I can proceed with some 6.7 I guess. Okay, and if I just shift the decimal, 0.067, that's it, 0.067 I can get out of it. Okay, I guess you understood. So here first what we did, we just calculated the molecular weight, number of moles we calculated from there. Okay, then the mole fraction formula, number of moles of ethylene glycol divided by the total. Okay, so if you just proceed with the calculation, it will come up to be something nearby 0.67. Okay, 0.068. Okay, close by only. I guess you understood. Let's proceed. Okay, calculate the molarity of the solution containing the, okay, at first you just go through the formula of molarity, that is the number of moles of solute present in the volume of solution. Number of moles can be written as given weight by molecular weight, so that number of moles can be replaced with W2 by M2. M2 is the molecular weight here, into 1000 divided by volume of solution in ml. Okay, so now the question is, calculate the molarity of solution containing 5 gram of NaOH in 450 ml solution. So directly I can apply the formula of molarity, that is given mass of NaOH is how much? They gave 5 gram. So 5 gram divided molecular weight of NaOH is 40 gram. Okay, into 450 ml into 1000. Into 1000. That's it. Okay, so if you just calculate this, your answer will come something like 0.278. Okay, I guess this is clear to you. Let's proceed. Okay, so here this is the molality. So molality is basically moles of solute that is present in a mass of solvent, in 1 kg of solvent, better to say. Okay, so again in the solute, moles of solute, you can break it down, W2 by M2, W2 is the given weight divided by the molecular weight into 1000 by mass of solvent, that's it. So here also same type of problem, calculate the molality of 2.5 gram of ethanoic acid and 75 gram of benzene. So molality is represented by small m. Okay, so that is 2.5 gram molecular weight of the given weight of the solute divided by molecular weight of ethanoic acid. Molecular weight of ethanoic acid we need to calculate. Okay, let's calculate the molecular weight of ethanoic acid, that is CH3COOH. Okay, acetic acid basically. So 12 plus 3 into 1 plus again 12 plus 2 oxygens are there. So 16 into 2 plus 1. Okay, so you will get something 60 gram. Okay, so 2.5 divided by 60 into 75 gram of solvent into 1000, that's it. If you just calculate this, your answer will come up to be 0.556 molal. Okay, I guess this is clear. Let's proceed. Okay, so that's all about this chapter. This is a very brief one short video where all the concepts are covered along with some numerical. Definitely whenever the live session will be taken for the PU1 for your KCET preparation, definitely the previous year question from these chapters will be done. By that time, if you are having any doubts related to this chapter, please make sure you are commenting me below, and do not forget to like, share and subscribe our channel. Thank you for watching.